Welcome back to another new video of Daishinfinity. In this video, we're going to talk about the derivative of the hyperbolic function of sine, which is the sinh of x. Now, it states that the derivative of the function sinh of x is equal to cos of x, so the hyperbolic cosine of x. And in this video, we're going to try and prove it using the limit definition of the derivative function. So before we dive right in, let's try and talk about the definition of the function when it's taking a derivative of it. So the derivative of any given function f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So since our function is sinh of x, we would normally put the sinh of x inside, but it would not help us at all. That's why I would like to use another type of way of writing sinh of x using the exponential function e of x. It states that sinh of x, the hyperbolic sine of x, is equal to the e of x minus e to the negative x over 2. Now we can use this fact to put all of this into our limit. So sinh of x plus h will be equal to e to the x plus h minus e to the negative x plus h and so on. So we are going to get the limit as h approaches 0 of e to the x plus h minus e to the negative parentheses x plus h over 2 minus e to the x minus e to the negative x over 2 and the whole thing over x over h. Now since we have the same denominator, we can use this fact to combine the fraction together. So we have the limit as h approaches 0 of e to the x plus h minus e to the negative x minus h using those properties, and then minus e to the x plus e to the negative x, because we have a minus in front of the whole fraction, so we're just going to use the minus to distribute it into all of the components. Now this whole thing over 2h. Now what we can do is we can combine, or we can use the property of the exponential function, the rules of exponents, to demonstrate it in another way. It will be a limit as h approaches 0 of e to the x times e to the h, because e to the a plus b is equal to e to the a times e to the b, so it's the same thing here, minus e to the negative x e to the negative h minus e to the x plus e to the negative x. Now let's find some common things here. Forgot the 2h. So we take e to the x and we take e to the negative x and then combine it here. So we're just going to get the limit as h approaches 0 of e to the x times e to the h minus 1. Then we take minus e to the negative x, e to the negative h minus 1 all over 2h. Now, I would rather use a positive here, so we are just going to distribute the negative into our parentheses, which would equal to just swap in the 1 and the e to the negative h. And now we have an addition of 2. So we can still state that we have a limit rule, that a limit of a plus b is equal to the limit of a plus the limit of b. So we use this fact to split those things up. So indeed, we are going to get e to the x over 2 using our property of constants, because x is independent of h, times the limit as h approaches 0 of, let me see, e to the h minus 1, e to the h minus 1 over h. Then we have plus e to the negative x over 2 times the limit as h approaches 0 of 1 minus e to the negative h over h. Now when we look at this limit, the limit as h approaches 0 of e to the h minus 1 over h, we have taken this into consideration when we try to derive the formula of the derivative of the function e or e to the x. Now we know this limit is equal to 1, so just watch the video and see why. So we can see that this limit is equal to e to the x over 2 plus e to the negative x over 2 times the limit as h approaches 0 of 1 minus 1 over e to the h over h, since e to the negative h using our exponential property is equal to 1 over e to the h. So now we are just going to multiply e to the h and e to the h on both sides, so that the e to the h on this denominator can cancel out with that. So we can have e to the x over 2 plus e to the negative x over 2 times the limit as h approaches 0 of e to the h minus 1 over e to the h times h. Using our multiplication property that the limit of any a times b is equal to the limit of a times the limit of b, where I will prove this one in another video using the epsilon delta definition, we can split this up into two limits. So we have e to the x over 2 plus e to the negative x over 2 times the limit as h approaches 0 of e to the h minus 1 over h times the limit as h approaches 0 of 1 over e to the h. Now this one we can say that this is equal to 1, since 1 over e to the 0 will be equal to 1 over 1, also equal to 1. And this limit we just talked about, which is also going to approach 1. So the whole thing is going to just be equal to e to the x over 2 plus e to the negative x over 2. Now since we have the same denominator, we can put them together in one whole unified fraction and say that we have e to the x plus e to the negative x over 2, which is also the normal definition or the standard definition of the cosh function of x. So I hope I've proven it, and I hope you guys enjoyed this video, and we'll definitely see us in another Daishinfinity video. See ya.